Go!
Alright, so we're going to learn about ellipses. Yay. So, you guys ought to watch this. I think I did a cool thing again.
Boring.
Whoa!
Boring.
Yeah, that's pretty boring.
That's the shape of your ellipse right there. How about that?
I don't get that one.
Okay, so students will be able to graph and write ellipses, equations of ellipses. What points do you need to know to write the equation of an ellipse? Well, I think you're going to find this section fairly easy. Most people do anyways.
Is it easier than the 8.3?
I think so.
That one was pretty easy. Like.
Well, ellipses are pretty easy too. Here's your handout that I just gave you. And what you're going to discover about ellipses is that sometimes they're elongated in the horizontal direction, and sometimes they're elongated in the vertical direction. And depending on how they're elongated determines whether you have a bigger number under x squared or a bigger number under y squared. So there is a way to find focus points also. Ellipses always have two focal points. Right here, if you take a look right here, there's a focal point here, a focal point here. Over here, there's focus point here, focus point here. I need you to be paying attention.
Oh my God. See? You guys, can you press pause?
No. Okay, so one of the things I want you to point out, to you is this equation right down here. Oops. This one. That helps you find the focal points. If you notice right up here, the letter C is referring to your focus length. You see that right there?
Yeah.
The length to the focus is C, and it's equal to a squared minus b squared.
Honestly, Russell, this is like the opposite of the picture.
I know it's a little bit blurry.
No, it is.
So, you'll have to live with that, or you can use your book. Oh, we got that. Now you can share that with your parents. Okay, so some other things you should realize is that the length of the major axis, you have a major axis and a minor axis, okay? The total length is 2a, and the total length of the minor axis is 2b. And so if you take a look here, this entire length right here is a. And so naturally, because of symmetry, this is also a. And so the entire length from here to here is 2a. Get it?
Wait, so Mr. Russell,
Yeah.
an ellipsis is just like an oval?
Yeah. Yeah, it's kind of like an oval.
It's like a square.
Okay, if you say so. This is apparently a square to George. That's
Yeah.
all right. And then notice the length here. This length is the minor axis. This length is b. This length, because of symmetry, is b also. So the entire length is 2b.
Whoa.
And again, the b and the a's are coming from these numbers that are under the x squared and the y squared. They will always come from underneath. So one of the things you'll want to do is make sure your equations are written in standard form. There's a standard form. There's a standard form. Now, notice the coefficients in front of the x's and the y's. The coefficient is a 1. So if you don't have a 1, then you haven't written it in standard form. Does that sort of make sense? So there should not be a 3, for example, up there in front of the x squared.
Only the 2?
Should not be a 2 either.
Nothing?
Nothing but 1.
Alright.
Okay? 1 is the coefficient on top. So, anyhow, I'll spend some time going over some problems, and you can use your cheat sheet, like I said, for the first couple problems. But after that, you probably should wean yourself off of it. Does that make sense? That's my recommendation. So, let's try a problem now.
Yeah, let's go.
All right, so we're asked to graph the equation, identify the vertices, the co-vertices, and the foci. And so I got some cool graph paper there. And I want to show you how to do this, so I'm going to rewrite this here, 25x squared. Okay, look, Michelle, go outside with Bea and talk out there. Seriously, go. No, we're here to learn. Okay, go ahead and talk out there. Yeah, take your book. Well, you guys talk too much. Hurry, because you're holding this up. Okay, the first thing I want you to notice is that this is not written in standard form. Someone please tell me, looking at your sheet, tell me why this is not in standard form.
It's not.
Well, first of all, there's no numbers underneath.
Oh, yeah, because the 25x.
There's a 25 here, there's a 4 here, and there's a 100 over here. The standard form should have a 1 over here, doesn't it?
Yeah.
And there should be no number. So how do we transform this? Well, that's what I'd like to share with you. You take the biggest of the two numbers here.
Yeah.
It looks like to me the biggest one is 100. We need a 1 right here.
Yeah.
So what I'm going to do is divide through by 100. Divide this one by 100. Divide this one by 100. Divide this one by 100. By the way, if you want to copy this down on your study guide somewhere, that'd be not a bad idea.
You're not a bad idea.
And, George, I'm really not in the mood.
I thought you would.
Okay. So, 100, that gives us a 1 here. Now notice what happens here. 25 goes into 100 4 times. So what you have is like x squared over 4. And over here, 4 goes into 125 times. So this cancels off with this, giving me 25 down there. And so I have y squared over 25. Okay? That makes sense so far? Yeah, they sort of switch spots, and that's a cool little way of remembering it. It might help you do these problems a little bit faster. But right now, it's in standard form. Now, one of the first things you should be able to do once it's in standard form is determine which way is the ellipse elongated. It's always elongated on the axis where you have the bigger number under here. So the bigger number is under the y squared, right? So it's going to be vertical.
Vertical?
Yeah. Okay. Now, how do you find these vertices and the co-vertices? Well, the vertices come from the major axis. The major axis is the longer axis. So they come from this number here. Remember, we're using a and b here. And this currently is a squared, and that's b squared.
That's 5.
So if a squared is equal to 25, like George is now saying, what's a?
5.
It's plus or minus 5.
Oh, sorry.
And so you can go along the y-axis and put the vertex. There's a vertex, vertice right there,
I see.
and a vertice here at 5 and minus 5, right? Now you can do the same thing over here. If this is b squared, then b is equal to
2.
plus or minus 2.
Sorry, listen.
So then you put this 2 here and this here. These are called the co-vertice. It's on the minor axis. So this is the vertex, co-vertice. And you know, you have another one over here, okay? So if someone wanted to, you could write the coordinates. The coordinates would be, and here's how I would do this. You could write this as -2, 0, and the other one is 2, 0. Now, let me show you a shortcut way of doing it. You guys ready to see the shortcut way of doing it?
Yeah.
2 plus 1 is 2.
No, we'll do it like this. This is the shortcut way. You say plus or minus 2, comma 0.
That's what I see.
then people understand, oh, well, there's two of them. Does that make sense? Instead of writing the plus or minus here, just write them both right there.
So the
So how would we write the vertices, the big one, or the major axis one? That's what we call the, huh?
Plus or minus 5, 0.
Oh, hold up.
0 plus or
0 plus or minus 5, there you go.
yeah.
So since this one's in the y direction, you'd write the other one as 0, comma, plus or minus 5. And that would give you your vertices like that. Okay, so there's the vertices. Now, as far as the graph goes, we just need to make this look curvy. And so, kind of curve up this way.
So
And it kind of looks
what's
like
your bossy
foci.
both side.
Foci. So we kind of curve it. It should look kind of circular a little bit, because actually circles are a special form, a special case of an ellipse. That looks pretty bad, but yours I'm sure will look better than mine. So then again, these are our 4 vertices. There's the regular vertices and the co-vertices. Okay, any questions so far? So now we need to find, you're right, the last step is to find the focal points. Where are the foci? Now, one thing you should always remember is that the foci are always on the major axis. And I gave you an equation. It said something like c squared is equal to a squared, I think, minus b squared. Is that right?
Yeah.
So you know what a squared and b squared are, right?
A squared was 4.
A squared is 25, because a squared is always the larger, is the major axis. And then minus 4, right? And so that gives us c squared is equal to 21. And you take the square root here, and we're just going to say it's plus or minus whatever decimal place, right? So probably want to go 1 decimal place as far as we're concerned. Square root of 21. Yeah, let me change my calculator. Square root of 21
Great.
is 4.58 or so, so 4.6. It's equal to 4.6 or so. Alright, so that means how can we list the focal points? Remember, there's a quick way to do it, like this setup here. It's always on the major axis, so that it's 0. And if you want to write it as plus or minus square root of 21, that's actually okay. You can write it like that. So these are going to be your focal points, or foci. Foci, F1 and F2. So then you put them on the graph. We found out that it's 4.6. So the focal points, let me make this a little bit thinner line and put them in. 4.6 is really close. It's like right there. And the other one's right here. 4.6. So there's like F1 and here's F2. Usually we use capital letters, and you guys could hardly see that, can't you? Let me try a different F2 and F1. That's still bad.
Did you have to do that 1 and F2?
Let me use black maybe instead. Black. Okay, so you can call them either F1, F1 and F2. So right there, 4.6 or so. So, any questions?
Can you redraw that?
Redraw it?
Yeah.
Nah, don't try it.
I'll tell you what I will do. I'll do another example just like it.
I can see it pretty good.
So, now, this one, they already have it in standard form, so it's going to be even easier. But you're going to find that most of the time you can graph these really quick because, well, this one's elongated where? on the x-axis, right? Whatever one of these numbers is bigger in the denominator is the one that's elongated on, right? So where are the vertices at? In this case, this is my a squared. A squared is this one. So if that's a squared, then what's a?
4.
No, it's plus or minus 4.
Sorry.
Alright, I forgive you this time. Alright, so then there's our vertex here and a vertex here. A vertice. Alright, and what about the vertices on this one?
3.
Yeah,
minus
yeah, it's plus or minus 3, right? Plus or minus 3. And so we're up here, right here, plus or minus 3. There's another point. And now you can kind of just make it kind of this really make it kind of, hey, I'm actually doing pretty good on this one.
Hey, not that.
Hey, I didn't ask your,
Where is that?
I'm gonna put you on toilet duty.
Where is that?
Oh, that's terrible. Yeah, okay, so I was being funny there. Okay, anyhow,
What happened to his face?
yeah. Okay, so if you had to write out the vertices, can you tell me the coordinates? Vertices. Okay. Hopefully you could say them real quick, right? And you can just use
Plus or minus 4, 0.
plus or minus 4. See, it's on the x-axis this time. So it's plus or minus 4, comma 0. And then what about the co-vertices?
0, comma, plus or
The
minus.
co-vertices. Okay, we're going to say what?
0,
0, comma,
plus
plus or minus 3, right? And now, what about the foci? The foci.
C squared.
You see, so what we have to do is a little calculation, right? That's why I showed you that little sheet. It says c squared is equal to a squared minus b squared. Now, a squared is always the bigger number, so right? So it's going to be 16 minus 9, right?
Equal to 5.
Is equal to
7.
7. So that's all right. We're allowed one mistake per period. And so anyhow, we get c is equal to plus or minus the square root of 7. And it's okay if you want to write your foci. Okay, it's got to be on the x-axis, right? You can write this as plus or minus square root of 7, comma 0. That's totally fine with me. Now, in practical terms, we probably want to know the decimal equivalent. So let me just do that real quick. Square root of 7. It's approximately 2.64. So c is equal to approximately 2.64. No. So it's somewhere, right about here. I'm going to say it's right about there. Now, the foci are always, always, always on the major axis. So you can call this one F1, F2. And now we've done everything. We did the graph, we did the vertices, co-vertices, found the foci. And I think you'll agree that this is pretty easy stuff, right? Simone? Now here's the thing, hyperbolas, the setup for hyperbolas are very similar. Just one small change. So make sure you get these equations figured out, practice them. Like I said, after a while, I recommend weaning yourself off this because you can probably do this without thinking too much. I mean, it doesn't take a whole lot, right? In the beginning, though, if you want to use your cheat sheet, that's fine. I'm not going to... All right. Sometimes we have to come up with the equation. So, on these sorts of problems, they give you some information and they want you to come up with the equation now. So I'm thinking, okay, if I have an equation, it's either x squared over a squared plus y squared over b squared equal to 1, or it's going to be like y squared over a squared plus x squared over b squared equal to 1. Now, the bottom line is that a, in this case, is always the bigger number. the bigger number is the major axis, right? And so some cases the major axis will be under X, which means it's elongated horizontally. Sometimes it'll be under the Y term, which means it's elongated vertically. Okay, so that kind of tells you which way the pancake is elongated, right? But based on this information, can we quickly determine which case we have? Well, we know what they've given us in this problem is a vertex. One of the vertices is at -7, 0, -7, which way down here, right? And that tells me this thing's elongated, you know, like this. That's something like that. Now we don't need the graph, so I just did a little sketch. But I know it's going to be this set up here. The y squared, I'm going to go ahead and, I don't care whether you write the y squared term first or the x squared, it doesn't really matter. You're going to have this set up here. You're going to have equals 1. Okay, so if that distance, that major axis is 7 here, then that means A is equal to 7. Does that make sense? Mm-hmm. And the number that goes under here is actually A squared. So A squared is equal to 49. There you go. So 49 goes here. Everyone okay with that? What's the covertex? The covertex is this one, which means this one's 4, right? And so if that b is equal to 4, then b squared is equal to 16. And so 16 goes here. And that's it. I mean, that's pretty easy, right? Huh? Oh, sorry. My big fat head's in the way. You weren't supposed to agree. That was a test. Now you need to... You're supposed to say, Mr. Russell, your head's not bad. My wife does this all the time too. She's in big trouble all the time. Okay. So sometimes you'll be asked to find the equation. Now, by the way, ellipses come up all the time in construction. No, sometimes you have elliptical windows that, well, the top of the window is elliptical. Sometimes you have tables that are elliptical. You know, they're not always square and rectangular tables. Sometimes you have really cool elliptical tables. And sometimes you have arches and bridges that are elliptical. And there's certain sound properties that you like about... I mean, this is what's really cool. You guys are starting to get the idea, what is the focus point? Well, if you have... There's a building, it's called the Mormon Tabernacle, I think. It's kind of shaped in an elliptical shape. And they have a focus point here and a focus point here. What they do is they put their choir at one focus point, and they put the congregation at the other focus point, sitting over here. And so, I don't know if you're into religious singing or anything, but it sounds really neat, I guess, because the focus point, all the sound waves bounce off the walls, and it goes to the focus point. Does that make sense? It's really kind of neat. If you've been in like a theater like this, I don't know too many theaters that have focus points, but you know, it's kind of neat. I don't know if you've ever played a pool table that has elliptical shape to it, but there are pool tables that have elliptical shape. It's like bumper pool. Bumper pool, they have bumpers in here, and it's kind of fun too. So that's neato burrito. Oh, one other cool thing. Think about this. There's medical devices that do this. Like, you might be sitting in the hospital, and right here you have what's called a kidney stone. And that's when you start to get to be like old fogies and stuff like that. You have kidney stones.
My mom has
Your mom's had one before?
she has a lot.
Well, what they do is they set up a medical device, and they have a emitter right here. It's at one of the focus points. They set this thing up, your kidney stone, so that it's at the other focus point. And then it starts sending out a bunch of sound waves out here. And all those sound waves hit here and break up the stone. It's pretty cool. It's like ultrasonic type. And it kind of vibrates the thing. And and vibrates and vibrates, and then it breaks. Finally breaks. I mean, I don't know for sure. I've never had this procedure done, but I've seen pictures in books that show how this works, and you might even see one in your book. So ellipses are pretty cool stuff. Pretty cool. All right, now you'd like to try it, right? And let's see if we can do this in 15 seconds or so.
Okay, right into the ellipse over here. So we have y squared plus x squared equal 1.
Man, yeah, I mean, it's like it should be done already. You guys are slowpokes. The major axis is where? Vertical, right? So that's 16, and this one's 9. Done. Now, they're not always that easy. I mean, sometimes you'll have a little bit harder. Sometimes they give you the focal length. Sometimes they give you the C instead. And so sometimes you have to find a squared. Remember, it's minus b squared, right? So sometimes they'll give you a vertex. They'll give you the focal length, and you got to solve for b. So keep in mind this equation comes in handy lots of times.
It's like the opposite of a diamond and zero.
Kind of, yes. Very similar to it. Alright, now you may not have known this, but the area of an ellipse is pi AB. Now this is kind of cool. You guys have all known that the area of a circle is equal to what? Pi r squared, right? Now let me show you something. The area of an ellipse, and this is kind of neat to know because airplane wings are often elliptical. I mean, a lot of airplane wings are elliptical. So if you wanted to find the area of an ellipse, you know, and you wanted to find out how much paint or how much metallic material you're going to need to cover it, this length here is like A, this length here is B. So if you want to find the area of an ellipse, it's pi times A times B. What happens in a circle is the same idea, but let me show you the difference. When you have a circle, A and B are equal. And so you have A times A, and so you get pi A squared. Well, the A in this case is often what we call the radius of the circle, so we call it pi r squared. Isn't that cool? So now you kind of have a better understanding of why the area of a circle is pi r squared. You have this length and this length that you're going to be multiplying. On an ellipse, those lengths are not the same. Well, so this comes up like sometimes when you have containers, and there might be a container like this hand lotion, and you want to find the area of this base thingy. And actually you'd want to find out the area of this paper thing that goes around and a few other things. Anyhow, marketing research shows that the hand lotion bottle with an elliptical base is easier to hold than a similar sized bottle with a circular base. So write the equation of the ellipse based on this information. Well, that's pretty easy. And then we want to find the area. Well, hopefully the equation only takes about 5 seconds, right? You have x squared plus y squared equal to 1, and then you have, oh, is this elongated in the x direction? Yeah, it is. It's elongated that way. So what length is this? 4. And so what goes here? 16. Right? That's your A right there. And so you want A squared here. What's this length? 3, right? And so what goes here? 9. 9. That was pretty easy, right? There's the equation. Now, what's the area? The area of the ellipse. We'll put area with little e here, right? It's pi times A, which is 4, times B, which is 3. We just say 12 pi. Area of the ellipse, 12 pi.
We don't do that 3.14?
No, you can just leave it like that. You don't have to. You don't have to solve. I mean, they often would rather have an exact answer than an approximation. So anytime you use a decimal for pi, you have an approximate, answer. It's not the true answer. So lots of times in math, we'll just prefer to have the pi written in there. Any questions on this one? Pretty easy stuff, huh? Okay, so now this one's a little bit harder to get our equation. Previous ones we were able to do in about 10 seconds, right? But now it's going to take 20 seconds.
I will try to do that today after class.
Okay, so what do we be knowing? Here you might want to do a quick sketch so you can get at least a good feel for what type of equation we should have. We are told one of the vertices, right? So negative 8 zeros over here. So I know that's elongated on the x-axis, so it's going to do something like that, right? So I want x squared, and if that distance is 8, then 64 goes under here, right? But now I'm told the focus point is at 4, 0. So what they're telling me is that c is equal to 4, right? So I need b squared, and what I have then is I have this little equation that we dealt with before. C squared is equal to a squared minus b squared.
So 16 is equal to 64 times b squared.
Yeah, so if we square that one, we get 16, right? Is equal to that is a squared. So it's 64 minus b squared. So now here's the thing, don't be too clever here. What we want is b squared. Don't solve for b. What you want is b squared. So what's the quickest way to do this? Maybe just subtract here 64, subtract here 64, and what do we get over on this side? We have negative b squared is equal to negative, huh?
48.
Is it 48? What is it?
48.
48. And that means b squared is equal to 48, right? Just multiplying through by a negative. Well, so now you know what goes here, right? The number that goes down here is simply 48. And now you got that equation. Can you guys think of where are students going to make mistakes? Yeah, they might solve for b. Where's another common mistake students are going to have? They're going to get these two mixed up. They're going to have the x and y switched. And that is a mistake. What if you switch those, then you're saying it's elongated on the other axis. And it's not true, right? So just be aware of those little things. Are you guys thinking the ellipses are hard or easy or what? They're pretty easy, right? So there's a little picture of all the stuff we've covered today. So what I'd like you to do, you guys are in luck because my first period class, they had to do that survey. So you guys are about a day ahead. So what I can do is give you Thursday, tomorrow in class to work on this assignment. And Friday, I'll probably give you most of the period, but I might give you an extra credit puzzle on Friday. Does that sound like fun? So I would finish the study guide today, and then tomorrow do the book assignment in class, and then Friday, you have Friday then free to do a puzzle. Okay, so that's it.